So physical quantities, right? So they can be in some sense physically recorded, right? Or, measured. Yes, they
Yes,
can be
sir.
quantified because they're quantities, and since they're physical, their measurements will be physically done. So they have units, and there are certain basic quantities. Yeah.
Yeah.
So what happens is कि हमारे पास कुछ quantities होती हैं. For example, we have length, we have weight, we have mass. Let's say not weight, mass. We have length, we have mass. We've got time, and further other lumens होते हैं. Lumens is light intensity. So we've got values and units which are used to represent certain physical quantities, right? So a standard unit has been set up, which is called the system international units, right? It's used to measure quantities in a standard form all over the world. Okay, so you have the SI unit form, and you have the imperial system, which is followed in America, right? Where they have pounds for weight, right? Pounds for weight or mass, let's say, and you know different quantities. For example, miles, they have miles and inches for measurements, feet for measurements in length, pounds for measurement mass, right? But since we're not studying in America and we don't have those values, for example, they have ounces for volume. So we won't be using these. We will be using SI units, which are used all over the world. They're called System International Units, right? So everything clear till here?
Yes, sir.
Okay. So for length, you'll have meters. For mass, you'll have grams and kilograms. For time, you'll have seconds. For volume, you'll have meter cube. Okay. So when you have these values, it is much easier to define certain quantities. For example, you're talking about I traveled this much distance. So if you're giving a certain value for that distance, it would be much easier for someone to understand, oh, he traveled this much. Yes. Make sense? So what are these? What is this word doing here? What is this word doing here? Before meter, what is this word doing here? What is this word? What is this? These are what you call prefixes. Okay. Because they're fixed before the word, right? What do? They give you the, you know, uh, ratio or the size of a certain quantity. So when you're talking about decimeter, you're talking about 1/10 of a meter. So it's 1 divided by 10. So it's 1/10 of a meter, or 10 to the power minus 1. When you're talking about centimeter, you're talking about 1/100th of a meter. So 10 to the power minus 2. Yes? Following? Are we good?
Yes, sir.
Okay. And when we're talking about milli, that is 1,000 of a meter. So 1 over 1,000, which is 10 to the power minus 3 meters. Nano is 9 zeros, right? And micro is 6 zeros. So you've got 10 to the power minus 6 and 10 to the power minus 9, respectively. Okay. Now these were smaller dividends. Yeah. Now we're looking at larger multiples. So larger quantities, right? So if we have kilometer, so that means you've got 1000 meters. So 10 to the power 3 meters. Okay. Are you understanding this concept? The
Yes,
indices
sir.
concept. Okay. And then you have giga, which is 10 to the power 9. And you have tera. You must have heard these concepts when you're looking for storage in your devices: gigabytes, kilobytes, terabytes. Yes,
Yes, sir.
megabytes. Mega is 10 to the power 6, which is not mentioned here. Okay, now let's talk about some errors. This is what you call the parallax error. Now, when you're taking measurements on any scale, right, there is a possibility of you having parallax error, right? What is parallax error? Parallax error is when you view the measurement from an angle rather than at perpendicular. Okay, अगर मुझे यहाँ पे measurement लेनी है, if I want to take the measurement here, right, and I'm looking from an angle to it, so there's a possibility that I might look somewhere that is not the actual measurement, right? So, for example, I take 4.4 rather than 4.3, which is the actual measurement. Or I'm looking from the other end and I measure 4.2, which is not the actual measurement. I have an error of zero point 0.1 here, negative, and an error of minus positive zero point 0.1 here, right? So, how do we fix that? We fix that by looking at the measurement perpendicular to where it is. Perpendicular means 90 degrees. Are you following?
Yes, sir.
Okay. So this is area. Area is measured in meter square or centimeter square or any length unit squared. Okay. So volume is any length unit. Volume is any length unit cubed. Right? It could be meter, it could be kilometer, it could be centimeter, it could even be inches. Okay, but it will be cubed. Why is it cubed? It's cubed because you're multiplying three dimensions. For area, you'll be multiplying two dimensions. So meter multiplied by meter gives you meter square. For volume, you'll be multiplying three dimensions, which is meter multiplied by meter, which gives you meter cube. I hope you're good with basic algebra. So this would make sense. Yes.
Yes, sir.
Okay. So volume is the amount of space occupied by an object. Unit of volume is meter cube or any length unit cubed, which could be inch cube or kilometer cubed, centimeter cubed, depending on what you have. Usually you get meters cube or centimeters cube. Okay. The volume of a cylinder is given by pi r square h. This is something you would learn in math. A measuring cylinder can measure the volume of a liquid. If you want an explanation to why this is, you can ask. It's basically pi r square is the base of a cylinder, which is multiplied by the height, giving you volume. So you got the area of the cylinder multiplied by the height of the cylinder. Okay, which gives you the volume. A measuring cylinder can measure the volume of a liquid and ensure. Okay, so ensure the cylinder is upright on the eye level with the meniscus. Okay, what is a meniscus? Have you heard of this term, meniscus? So meniscus is a property of liquids. Right? What happens is liquids have a tendency of they have a property which is called surface tension. Okay. Yes.
Yes, sir.
So due to that surface tension, what happens is you have this shape forming. Say this is what you call a lower meniscus. A lower meniscus looks like a concave bowl. Okay, as such. So you look at the base of that meniscus and you measure it perpendicular to where the measurement follows. This is called an upper meniscus, and for this you will measure the upper portion. Okay, make sense?
Yes, sir.
Now measuring time. You can measure time through a stopwatch. However, one of the uh, methods that is used in practicals in physics is using an a pendulum, right? What does a pendulum do? It swings from side to side, right? And it has a certain time from one side to the other side and back again, right? So one oscillation is what is the word used for movement of a pendulum from to and back. This portion. Okay. So this is the time taken for one oscillation. This is what you call an oscillation. It is the movement from to and back. Make sense?
Yes, sir.
Say. So what you do during this time is you have a stopwatch and you measure the time for one oscillation. Okay. For example, let's say that is 5 seconds. Now, during your experiment, what you'll do is you'll let the pendulum go and you'll count the number of oscillations that happen during that experiment and you'll multiply that by 5 in order to get the total time for your experiment. Okay, makes sense?
Yeah, okay.
Okay. Now, scalars and vectors. Scalars and vectors are the basis for our entire physics. So, yeah. A scalar quantity is a quantity that has a magnitude and a unit, but it does not have a direction. Yes? It is not direction dependent. Make sense?
Yeah.
Say. However, if you have a a vector quantity has a magnitude, a unit, and a direction specified to it. For example, if I'm moving and I do not specify where I'm going, and I travel 10 kilometers, I traveled a distance of 10 kilometers. Yes. So, distance. So, since I did not mention any direction, distance is a scalar quantity or a vector quantity?
Scalar quantity.
Scalar quantity. Now, if I specify that I moved 10 kilometers in the direction towards north, so now that I've specified it the direction, I have made this a vector quantity. Now I have displaced myself in a specific direction, right? So this property of having a direction calling displacement. So what is displacement now? Scalar or vector?
Vector.
Vector quantity. Exactly. So forces, any force is vector quantity. Gravitational field, it has the pulling force which is downwards is a vector quantity. Electrical field has a specific direction. it is a vector quantity. Weight acts downwards towards the gravity, it is a vector quantity. Velocity is speed, but in a specific direction, it is a vector quantity. Acceleration is in a specific direction, it is called a vector quantity. And momentum is based on force. So it is also a vector quantity. Okay.
Okay.
Right? Distance is a distance that is not specified direction ke saath, so it is scalar. Speed is not specified in a specific direction, it is scalar. Time is not specified in any direction, it is scalar. Mass is not specified in any direction, it is scalar. Pressure is scalar. Energy is scalar. And temperature is scalar. Now, when we'll be moving forward, we'll have a concept called work, energy, and power. You will see that the formula for work and the formula for energy are the same. However, energy is scalar and work is vector quantity. Make sense? Why? Because work is in a specific direction, whilst energy is not in a specific direction. Similarly, work and energy have the same units, and so do speed and velocity, and distance and displacement have the same. They have the same units. Yes. However, the addition of a direction or being in a specific direction is what causes these quantities to be different, to be scalar or vector. Okay.
Okay, sir.
Now, when you're representing vectors, what you do is you have an arrow and a line, which shows the direction of the force. The size of the arrow shows the, you know, magnitude, and the arrow shows the direction. Okay.
Okay, sir.
Now, when you're adding scalars, so yeah, it is ordinary arithmetic. Basically, when you're adding scalars, you either add them or you subtract them directly. Okay.
Okay.
However, when you're adding vectors, it is geometrically evaluated. For example, if you have this shows a vector which is in this direction and a vector which is in this direction, and they are perpendicular to each other, right? Now, do you know what the Pythagoras theorem is?
Yes, sir.
Right? So, can you tell me what that is? It says a square plus b square is equal to c square, where a and b are the perpendicular sides and c is the longest side, right? So a, b, c. A squared plus b squared is equal to c squared. And if you just want c, which is usually the case where you are getting the resultant force, right? The resultant force will be c. So you'll do this, whereby you take the square on c and you put it on a square plus b square. Make sense? यहाँ तक बात समझ में आ रही? Are we good?
Yes, sir.
Okay. So moving forward, let's look at a question जो यहाँ पे इन्होंने place किया हुआ है. For example, you have 11 kilometers moving northward and 11 kilometers moving eastward. सही है? So what happens is this is the displacement of an object 11 kilometers north and the displacement of an object 11 kilometers east. right? So what happens is you put them together and your resultant force is placed as such. Okay.
Okay.
उसके बाद you'll apply these forces यहाँ पे and then you get this answer which is your resultant force or your resultant speed.
Okay, sir. Can you solve one question for this?
We can. Okay. Can we solve one question for this? One second. Let me pull up a question. Okay. Physics. Okay. Can you see these questions?
Yes, sir.
Okay. So this is what the questions usually look like. Okay. I'm trying to find one where you could apply Pythagoras. You can, as far as we're concerned right now, I can't find them. So let's look at the question that they've given in the book.
Yes, sir.
We look at the question that they've given in the book. For example, अभी दिया. Let's say we have an object that is moving. It has an upward force of 3 newtons and it has a rightward force of 4 newtons. So, what would the resultant force be? Can you tell me how you would solve this question?
3 square plus 4 square.
Sorry, could you say that again? Sorry.
3 square plus 4 square.
3 square plus 4 square, and that is equal to, let's say अगर ये a है, so this is equal to a squared, right?
Yes, sir.
So what do you do now?
Find the square of 3 and 4.
So what is that equal to?
9 plus 16.
Yes, 9 plus 16.
9.
So this becomes
25 square.
25. Yes, it won't be squared. This is just 25. On the square, to remove कर दिया ना, because
Ah,
4
okay.
squared. Yeah, so this is just 25 and it's equal to a squared, but we want a. So what will you do now?
Square root.
Yes, we'll apply square root to both sides, right? So a square यहाँ पे and this square root cancel, and we apply root to this side. Now, is 25 a perfect square?
No.
Can you tell me the perfect squares from 1 till 6? What is 1 squared?
1.
1. 2 squared?
4.
4. 3 squared?
6. No, 9.
9. 4 squared?
16.
16. And 5 squared?
25.
25. So what is under root 25?
5.
5. So you have 5 newtons. Understood?
Yes.
Okay. Now, what if you have an object and it has a force on this side, which is 2 newtons, and a force on this side, pulling it to the left, which is 3 newtons. So where would it move and what would the force be?
It would move on the right with 3 newtons.
Yes. Uh, 3 newtons or how many? Because they're in opposite directions, right? So what would happen? They would subtract,
So,
right?
yeah, 3
If they
1.
subtract,
1
so
newton.
yes, 1 newton to the right. Okay.
Okay.
Now moving on to motion, we're looking at distance time graphs. This is a larger concept, right? You know what is the relationship between distance, time, and speed? Yes. What is the relationship between these three terms? Have you seen this triangle made before? Have you ever seen this triangle made before?
No, sir.
No. Okay. Right. So this is the distance, time, speed graph triangle, right? So what happens in this is you have distance over time gives you speed. Okay. Distance over speed gives you time. Time multiplied by speed gives you distance. Do all of these make sense?
Yes, sir.
Okay. So now that we know the relationship between all of these, we have graphs that represent movement of an object. Now, this is a distance time graph. So it shows from 0 seconds to 4 seconds, the object has moved how much?
4 seconds.
Uh, from 0 to 4 seconds, how much has the object moved? Distance.
4 centimeter.
Yes, 4 centimeters. Right? Now, can you see that there is a constant slope here? The slope is not changing. There's a constant slope from 1 to 4 seconds. Yes.
Yes.
So here we say the speed is constant. Yeah.
Yes.
Okay. So speed is constant. What is speed again? Speed is distance over time. So do you know how to take out gradients in a graph?
No, sir.
No, you haven't done that, right? So in a graph, when you're taking out gradients or slope की value जो होती है, which is called rise over run in maths, we take the values of y, the second value, and we subtract the value of y1, and we take the value of x2 minus x1, which is the change in the x axis, which here is time, and the change in y axis, which here is distance. Now, we know that change in distance over time is speed. Yes,
Yes, sir.
right? So, if we're moving 4 centimeters in 4 seconds, can you give me the speed? Can you give me the speed? What is 4 divided by 4?
1.
1. 1 centimeter per second. So we can write s minus 1 or we can write 1 centimeter per second. Make sense?
Yes, sir.
Okay. However, अब यहाँ पे देखो. यहाँ पे is the object moving? Can you say that the object is moving? There is no change in distance. Can you say the object is moving? The object is not moving. Say the object is what we call stationary or at rest. Make sense?
Yes.
Okay. So if it is stationary or at rest, so it's not moving, is it?
Yeah.
Okay. So if it's not moving, so it should not have a speed, should it?
Yes, sir.
It should not have a speed, no? So the speed at a distance time graph, when the line is horizontal or parallel to the axis, it is zero. Speed is zero. Okay.
Okay, sir.
So let's keep it till here for today. I guess if I give you more concepts, we'll have a bit of a confusion. So are we good for today?
Yes, sir.
Would you like to continue further or keep it here?
Stop it here.
Okay. Any further questions up until now that we've learned उसके बारे में?
No, sir.
Okay. Everything is clear?
Yes.
Okay, the first thing that we'll do tomorrow is look at questions for these concepts, and then we'll look at further this chapter, how much is left. Okay, only speed time graphs are left and a bit more. So we'll do that because it's a bit large. This portion. This is your first unit, right? So we've done 1.5 portion of your first unit. Okay,
Okay, sir.
office.
No.
Allah Hafiz, thank you.